So I send this file functions. We will need to use it from line 30 here. But there are functions in that file that we need to use. And there are a number of packages that we need to use. So these three functions come handy if you want to write our results into a document. So I have installed them already, so you have to install them from line 1 to 3. And all these packages which you may have installed them or not. If you have not installed, you just have to install before line 10 to 19. So set a working directory and then we load the function. So let's change the data to the oil shocks, but that's short. Again, remember we made this into an XTS object by looking at and seeing the date column as date. So this is quarterly data. So we'll use this line, we comment this, and we'll use line 37 for quarterly data. If it's daily data, you can use line 34. And then we continue to load the data. Okay, so we are going to create, so this line, let's do them, line 46. We are going to use our variable in the table to create, because when you make the output, you want the variables to show. So you can look at our file. I know there's NPR, there's DRY, we have OIP, we have DRY, we have NER, PPI, and lastly, we have NPR. You can close these things. Then again, we modify it as an object. Then this one here is the first option. We just want to pick out the column names using this as an index. So we can use the first one, OIP. I asked you to get some dates, important dates that may be useful for the length of your data. Did you have any? So I want those dates to show in the results, in the plot.
Yes, 2020, 2022.
So to be in a year, month, day. So which month in 2020?
March.
3, and maybe you can do 30 or 31. And that was, you said COVID, right? So we can name it as COVID. Do you have another?
2022, March, the start of the Russia-Ukraine war.
03.
31.
Any
and
other?
We can do 2010 September.
So which one again?
2010 September.
21,009, 30.
This will be the start of oil production.
Okay, so we can say oil discovery or production. Any more?
We can do 2007.
207. What was it for?
That was the official adoption of inflation targeting in Ghana.
Okay.
So the behavior of the MPL.
So 2007, which month?
Let's use March.
Okay, so March, then 31.
Then we can also use 1992.
So
First quarter of 1992.
So you may look at this paper, actually, it was also on macroeconomic variables.
92, we can start also from March.
We got to 92. So what happened there?
That's the adoption of flexible exchange rate.
Maybe that's okay. Any days, as long as it's within the length or the sample period, that's fine. Let's capture them. And so we have done oil production inflation target. Then we create an index for them here, the last one. You can delete the rest. You shouldn't forget to keep the T for it to capture the period. So now we are going to partition the data for the period that we have set. So we basically bring the whole all the periods here, but this time we have to make them characters because they are just going to put names there. So we have the COVID, Russia, Ukraine. We also have oil production, inflation targets, and flexible exchange rates. So we should have an idea of what we expect to happen at those periods. Do we expect a higher connectedness or shocks to show, or we don't? Okay, so now let's see Russia, Ukraine oil production, inflation targets. There was, okay, announcement is the inflation target, right? Okay, so
Official announcement here.
let's again. Yeah. Okay, so TVP-VAR, we initialize, I think 10 is okay. Then we have our forgetting factors here. And these are the coefficients that will be out of the data, the estimation. So we can initialize them. What's happening? Covariance is not true. You remember I said that we need a covariance to work because that's what is used in the estimation. So that's not coming, then it will give us a problem. So let's see. It's numeric, logical, not true. Let's look at the data, what is inside. You see what's happening? The last quarter, the last column, that shouldn't be there. That's what is giving us the trouble. So you need to fix that. So let's look at the dimension of the data here. What's the dimension? Just need to remove that one. Why? 6, it should be 5. So what we can do is from here, after we make it a zoo object, we can make it raw, assigned to raw, column 1 to 5. So from here, it is not going to pick. So if you run raw here, because it is raw that we change to Y. So if you view, yeah, so it's gone. Let me comment it because you may not need it. So now we have to run from here to pick the new raw. Then Y can be raw now. Pick the names of Y. You don't need this. And then we should have a covariance. Let me try one more time here. I'm trying one more time to see what's going on. So let me run from here again. I may not need this column, but date is date. Okay, so I think I see where the problem is. See, the format is YQ, but the data is saved as month, year, month, day. So we can still use this line 34 to work. And based on that, we shouldn't have any challenges. Okay. So we don't need this line now. Let's set our periods. And we can go back to this to see if it works. Y. Okay. We set the index and we set the column names. Yeah. Okay, so and we can write it to CSV if you want. So we don't need these lines. We are back to where we started from. Okay. Now, this should also not give us, in fact, this doesn't give us problems. So set this one as well. And then the TVP-VAR should work now. This is a warning. Anyway, based on everything that we have done, this should work fine. Okay. So we are calculating the indices and we just want to see them as percentages. And after that, we are going to plot them and see. So that's done. Now, here, this is where we want to get all our results. So we create a folder here. And when you create the plots, we put them in that folder. So we want to save our plots as PNG, and they should go into this folder we have created up here. And for each of the plots, we give it a name and dimensions. Okay. And this is the plot that we want to do. So we are going to plot the total here. So you see total. You see total here. That plot will go into this part. And this is a straight line through the date column. We put a box around it. You don't need a box. And look at this line 122. When you create a folder, you create an object. When you finish using it, you need to close it. So you open it, then close. So this line will close it so that you can open another one and close it. So that's the purpose of that one. And the rest is just aesthetics. Okay. Then we can do another one. So total directional. We are going to create a new plot, and it is 2. So that's why it's directional. So we can do also from, which is here. And now the K, let me show you where K is. K is where? K is somewhere up. So look at K. K is the number of columns. So if you look at the loop down here, because the 2 is for every one of them and from is for everyone. So for I in 1 all the way to K, so for all the columns. Okay, that's why we have that. Then we have the net as well. And we can do the pairwise directional. So we have I and J. So I will be to and J will be from. And if you look at line 160, we have if I is not equal to J, so that they are not the same. So that will be off diagonals, if you remember the code. So off diagonal. So that one, we just do the plot for I and J, and we put that, we get the plot for that. Then you can plot the average as well. And we put it in a Word document. So in the Word document, so all of these, from 115, there will be pictures that we put in the folder. But when we get to 186, we are going to create a Word document, and all these plots will go into them. And there's even a table that we'll put there. So here, this table, we are going to create a net table, and we also put that in the Word file. But see, the table may be long. I think for this number of variables, we'll have a problem. So if the variables are many, the table will be long, and it may not fit on the landscape. But we have created the Word file as a landscape. I haven't checked for how to change it to portrait. It's originally in portrait. I haven't checked how to change it to portrait. But with this number of variables, I think they can fit. So that's the challenge with putting your table into the Word document. Okay. So we pick the tables that we want, and we put them in the table. So all these are tables of each of the results. Let me just make one mention on this, the piping function. You may use it or not. So if you look at this line here, line 189, the percentage sign and greater than sign, we call them the piping function. So what happens is that if you don't want to run several lines of code, you can use the piping function to connect them. So you would have run this line here, then you come and run another line, which will start with an object assigned to a function. Then you go and run another line with an object assigned to a function. So, but with here, you realize that there's only one line basically. So this function connects this function, and it also connects that function. So it makes 3 lines in one. Otherwise, you have to run 3 separate lines. So that's the piping function that we are employing. So all these ones, you see them to be long, but they are bits and pieces from the basic R coding that you would have done or you've seen it somewhere. So if you have some background, these ones will tend to make sense. And it's just a matter of arranging them and putting them where they should be to give you the results that you want. So if everything is okay, this part is a general thing that I put here. You don't need it from 280, so you can forget about it. So if everything works out and we run the lines, we should get the results as we expect them to be. So we can start from 112. So 112, once we run this line, a folder will be created in our working directory that we can go and check, and it's called plots. So if you go to our working directory, you see that folder called plots. And at this point, you will see an empty folder, but there's nothing there. So this is the plots folder. Okay. There's nothing there. We are now going to put values in them. So we can start with this line. Hopefully, everything works out as we expect it to be. So 1, 2, 3, 4, 5, 6. Yes. So the file has been plotted and saved. We can see it. Let me show you the plots. See how it looks like, if it's nice or not. Okay. So what is happening is that the length is too wide. You can just check the code if you can reduce it. So if you bring it to about say 40, like we did the last time. So let me show you the line that will help us edit the plot. So if you come to the plot function, we look for where we can modify the y axis, and it is the y limit. So here. So we can change this to, we said 40. So if you run it again, we should have a more compact plot. So again, 1, 2, 3, 4, 5, 6, bam. And hopefully it will be better. So this is it now. This makes more sense. So the lines that are in there, those were the dates that you gave, which means you are missing this area. There's a lot more activity here that you may need to find reasons for, that you may have demarcated or you may want to demarcate. So because you are highlighting some areas, so you have to be clear and highlight, let's say, better areas in code. Because now, if you have highlighted some areas, the question is why not these ones? And of course, you can always edit the code with the date to make those ones show. Okay. And you may also edit them from maybe beginning to end, so that they will stay within a range. So maybe you can start from here to here. So that's fine. We can run all the remaining lines, and they will show they all go into our plot. Let's look at the y limit for them. 140, that may be too much, but you see, that's not the point. We can always edit that part. Just make sure that the codes work. So try this one too. Yeah, so that one also came. We have for all of them. We can look at some of them briefly. Yes. So again, realize that the 140 is too much, so we can change them to 80, for example. Okay, so all of them. So this is OIP to all others. So all of them are there. Once you create a folder, so now we have 6. There will be a lot once you finish. So we can do from as well. Now we have 11 files. You can do net. That gives us 60. You can do pairwise. We have 36 because they are pairs. Then we can look at the average. So the average, we plot it within plot. We are going to put that one in a table. Yeah, because that's the table one. This one doesn't have to be a plot. And so let's go. Now we can create our Word document. So that is created. And when we run all these lines, as we have explained, then when we end here, I'll show you. When we end here, then the document will be saved with this file. So we can go and open the document and see it. So we are going to be running from, we've run this one already, so we can start running from here. So So from here, this is just some variance covariance metrics. No, this is actually net. So net table. So we will see it in the Word document. And the function that's giving us is the flextable. Okay. And we want to append the other one. So come on, append the net and save as CSV. We pick them in table form. So if you want to see this, we can make it cable and it will look nicer for us. Pick one. So cable. So this one is better. So please take note. So this table here will give them as a list, and that is this one here. But if you put cable around it, then it will become a proper table. And this function is from the knitr package. So we proceed. And then finally, we can print the document, line 277. Okay, so before we open the document, I want to show you the folder with all our plots in there. So all the plots that we want, they are here, 36 plots. Okay. And when we go into the working directory, we can see our document. We said connectedness results. So that's the file. This may just cut your work short so that I don't have to copy and paste. Yeah, so all the ones that we wanted to see that we plotted, they are here. They are also the same ones in the plots, the plot folder. Okay. The only thing that you have to do to modify the length of the plot. So this 100 is too much, not comparison. If that is 2 or even 65. This can go up to maybe 35. This can go up to 40. And 30 will be fine for this. For the net, 40 is fine. So look at this place is notable. Okay. So one challenge. So you see there's something wrong here. The first column is missing from this table. So we can just pick that from the R output and place them here.